Now, the another method to design the algorithm, that is the greedy method. Greedy method. This method is also used to design the algorithm. Now, as a name, we can understand about that greedy method. It means that in this method, we are quickly move towards the solution. We move towards the solution without fearing about that we will get the feasible solution or not. We will get the feasible solution or not, or we will get the solution or not. So in the this method to find the solution, there is no guarantee to get the best solution globally. There is no guarantee to get the best solution globally. Basically, this method, this is the optimization technique. Optimization techniques, and this method maybe gives the best solution locally, not globally. And in this method, select we always select and assume that we will get the solution that will be the best as globally. That will be the best as globally. So, so in this method, there are different problems which we can solve here by using the greedy method. There are three major problems here. One that is the minimal spanning tree. Minimal spanning tree. Spanning tree. Minimal spanning tree. Now another problem that is the fractional knapsack problem. Fractional fractional knapsack knapsack problem. Now third problem, that is the single source shortest path problem. Single source shortest path shortest path problem. These are three problems. These are major three problems which we can solve using the greedy method. We can design the algorithm of these three problems by using the greedy method. Now let us see here the first problem, that is the minimal spanning tree. One thing is here, we should know about the minimal spanning tree. What is the minimal spanning tree? Basically, the minimal spanning tree, to find a spanning tree from the from a graph. We find a spanning tree from a graph which has all the nodes of the graph, which has all the nodes of the graph, and the total cost of that tree will be minimum. The total cost of the tree will be minimum. For example, there is a graph and that graph has some cost. The edges of the graph have some weight, and the total weight of the graph, that will be the addition of all the weights of the edges. That is the sum of all the weight of the edges. That is called the cost here. So in minimal spanning tree, the spanning tree, that is a tree. That is a tree which had all the nodes of the graph from which we are draw a spanning tree, and the cost of that spanning tree will be minimum. So in this way, we can find the spanning tree from the graph. So there are two again there are two methods which are used to find the minimal spanning tree. There are two methods which is used to find the minimal spanning tree. One is the Prim's Prim's method or Prim's algorithm. Prim's algorithm. And another method, that is the Kruskal algorithm. Second, Kruskal, Kruskal's algorithm. Actually, these both are the mathematician which gives the algorithm, gives the method to find the spanning tree from the graph. From the graph. So now let us see here the first method, that is the spanning tree. First method, that is the Prim's algorithm. First algorithm to find the minimal spanning tree, that is the Prim's algorithm. First one, Prim's algorithm. Prim's algorithm. Basically, Prim's algorithm is used to find the minimal spanning tree from a given graph. From a given graph. So, how we find the minimal spanning tree graph, minimal spanning tree from the given graph by using the Prim's algorithm. So, what will be the step to find the minimal spanning tree from the graph? So when we use the Prim's method, then the first step, we select the edge from the graph. Initially, we select the edge from the graph which have minimal cost or weight. Finally, initially select the edge with minimum weight oblique cost, minimum weight oblique cost. So first we will see the graph and then select the edge which has the minimum cost or minimum weight. Then another step second, then we find the all adjacent edge from the both node of the selected edges. We find all the adjacent edges of the both node of selected edges. So in all the selected edges, in all the adjacent edges, what will be the minimum? What will be the select the minimum edge from all adjacent edge of the selected edge. All adjacent edge from the selected edge. So and proceed so on and proceed so on. So here let us see here if with the example. For example, there is a graph with six nodes A, B, C, D, E, and F. A, B, C, D, E, and F. There is a edge from A to B. This is the 3. And the edge from A to F, that is also 3. And B to F, that is the 16. And this one 12, this one 10, this one 11, this one also this one 14, 14 here, yes, 14 here, and here this one is 6, 6 here, and another this one, this one, this one is here 15 and 13. This one 13, this one 15, and edge from here to here. That is the 8. This is the graph. So what will happen? How to apply the Prim's algorithm here to find the minimal spanning tree? So in first step, we select we select the minimum edge. We select the minimum edge this from this. So there are two edges here, A to B and A to F. There are two edges, A to B and A to F. A to B and A to F. So what will happen here? What will happen here in step 1? Not coming in. Let us see here. So in both two edges, we can select anyone in first step. We can select anyone from both edges in first step. So for example, we select A to B. A to B we have selected. We have selected A to B. Then what will happen again? Then we see all the adjacent edges from A and from B. All adjacent edges. So all adjacent edges 1, 2, 3, 4, 5. 5 edges here. 10, 13, 16, 8, and 3. So what will be the minimum? Again in second step, A to F, this has the minimum cost. Then we select A to F in second step. In second step, we select A to F. We write the all steps separately. We write the all steps separately. We can write the all steps separately. So first step A to B, second step A to F. Again, we see the all adjacent edges from B, F, and A. So there is 10, 15, 13, 16, and 12. So what will happen here? 8 is also there. So the 8 is the minimum. Then we select A to B. A to D. This one. This one is we have to select A to D. In third step, we select A to D. Now come to the fourth step. Then again we see the all adjacent edges from A, F and D. Sorry, B, F and D. And D we have taken all the edges. B, F and D. So what will be the minimum? Then we find that B to C is a minimum as with cost 10. So we select the B to C in fourth step. In fourth step. Now comes to the next step. We again see C, B, F, E, and D. We again D, B, C, D, and F. So what will be the minimum? The C to E is a minimum, yes, that is the sorry, in fifth step. So in this tree, we cover all the nodes, cover all the nodes. Then this will be the spanning tree of this graph. Spanning tree of this graph. So see here, the spanning tree of this graph will be like as again A, B, C, D, E, and F. 3, 3, 8, 8, 10, and sorry, not direct graph, and 6. Yeah, in this tree, and it will be the tree, and in this tree we have shown all the nodes which are available in the graph. So the cost of spanning tree, cost of this spanning tree, we should add the weight of the edges. So 3 plus 3 plus 8 plus 10 plus 6. Then this will be the cost of this spanning tree. That is the what will happen? How much? I think 3, 3, 6, 8, 6, 8, 14, 14 and 10. 10, 24 and 6, 30. 30. The cost of this spanning tree will be 30. So in this way, we can find the spanning tree from the graph, from the given graph,